Hello and welcome back to my channel. My name is Piyush. This is day 51 in CK 2025 series. In this video, we'll be doing a deep dive into admission control in Kubernetes. What it is, how does it work? We'll be doing the demo of all the default admission controller that are enabled in Kubernetes, how to enable any additional ones, and how does it actually works. Okay, so without any further ado, let me just share my screen and I can just show you about the demo that we'll be looking into. But before that, we'll be just doing a quick overview uh, of the basic understanding of the concept. Okay, so, what exactly is admission control in Kubernetes? Okay, it's basically a piece of code that intercept requests to the API server after you are done with authentication and authorization. Okay, so how does it work? So, whenever you make an API call to the API server, let's say you want to create a new pod. Okay, so first the request goes to API server, then API server performs authentication and authorization. So that is done over here in this step. And after the request has been authorized and authenticated, after then the admission controllers are invoked. Okay. So this is basically a piece of code that intercepts your API call after you are done with authentication and authorization. Okay. Now there are different special controllers. So we have mutating webhooks, we have validating admission policies, and we have validating webhook. Okay, so what are these? So these are basically the type of controllers that perform certain actions. Okay, so there is validating webhook. Validating webhook is it, as the name suggests, it validates your request whether it is allowed or not allowed. Okay, so it validates, for example, there is a namespace in which you want to create the pod, and let's say the namespace does not exist. So in that case, your request will be rejected from here. It won't make any changes to your request, or it won't make any changes to the object. It just validates whether your request is valid or not. Okay, it's validating webhook. Then we have another type of controller, which is mutating webhook. Mutating means it actually makes certain changes as per the request and response. So it mutate the object from one state to another. It makes certain changes. Okay. So mutate is the word that you need to take care of, right? It changes something, it mutates something. Then we have validating admission policies. So these are again special type of policies that works on validating. Okay. So these are special type of controllers or admission controllers that you have in Kubernetes. Some of them are enabled by default. Some of them you can enable it yourself. You can write your own controller as per your requirement as well. Now, once the request is accepted, it's not rejected, it's valid, and these plugins do its work, then the object state will be changed in HCD, like, which is a data store for Kubernetes, right? So for example, you are creating a new pod, and once it is done mutating and validating and applying validating admission policies, after that the request is valid and it made certain changes to it with the help of mutating webhook. Then the pod will be created, and the details about the pod, its state, and all the configuration will be stored in HCD over here, right? So this is basically it. So the state, it goes like this. So you have your user making API call. Okay, the API call then goes to your API server, and then certain steps like authentication, authorization, these steps will be performed to make sure your request is valid, make sure the user have enough permissions, make sure um, all the required things under authorization and authentication. And then um, once the authorization and authentication is done, then webhooks are called, or the admission controllers are called. And once the request pass through it, once it is accepted, then the changes will be made to HCD. Now this will be only done when it is accepted. If it is rejected for some reason, then the response will be sent back to the user that your request like you will get an error. I will show you once we do the demo, that invalid field or invalid request, something like that. Okay, so this is how it works. Now we have admission webhooks. So there are two type of webhooks, which we just discussed as well. So we have mutating one, which changes the object or which can modify the object as per the requirement, and then we have the validating webhook, which only validates the request and the object, like if it is valid or if it is something that has been defined in the webhook configuration or not. Okay, so these are the most used webhook that we have. Okay, let's go to the next one. Okay, so why do we actually need these webhooks or admission controllers? The answer is simple. It is used to enforce strict policies on what is allowed, what is denied, and if it is allowed, let's say if the user has certain permissions, then the user should be able to create these many resources, not more than that, right? So it provides certain policies, it provides certain restrictions on what is allowed and what is not allowed on the cluster. Okay, now to call the webhook in the request, there are certain methods, like you can pass the URL of this URL is nothing but the endpoint of the webhook, or you can provide the service reference. So the way you do it, let's say you create a webhook. Okay, this webhook will be running as a pod behind a deployment. Okay, and then you expose it with the help of a service, right? When the deployment is exposed via a service, that means it has an endpoint, right? And this endpoint can now go over here, okay, in the service reference. And if you are using a DNS record, then you can use the URL as well over here. So you can provide any of the reference for the URL or the service reference depending on how you have created the webhook. And yeah, so if the deployment is down, if let's say if the pods are down, or if somehow the services are not um, exposed properly behind this deployment, then the webhook will fail. Okay, you will get the webhook failure message, or you get the connection refuse. There are different errors that you will get if the service is not working or if the endpoints are not exposed properly. Okay, now let's look a bit more into the flow of admission webhook. How does it work? Okay, so a client makes an API request. This client could be your like any user making request through kubectl or any other third party client. Then API server performs authentication and authorization. Once that is done, then mutating admission webhook will be called. Okay, mutating admission controller will be called, which then call the mutating webhooks. Okay, so it provides the review and response. That means this webhook will review the request and then provide the response. Because this is mutating admission webhook, that means it will make certain changes. It can make certain changes to the request or to the object. Then object schema validation is done over here. Then validating admission policy. This particular controller will take an action and it will validate the request with the policy. If it is accepted, then good. Else it will throw the error over here, and the response will go back to the API client. The same way validating admission controller will be called after this, and then the review and response will be done through the validating webhook. Now if the request is validated, then it will update the state of the object to the HCD, else it will go back. Now this all process happen in two phases. Okay, so the first phase is mutating admission, which is till here. The second phase is validating webhook, which is from here, which involves validating admission policy and validating admission webhooks. So if the request is failed or if the request is rejected in even at the first phase over here, the entire request will be rejected. Okay, because let's say if the mutating webhook says, okay, this is not allowed and this is something that I cannot change, then go back and make certain changes to the request and send the request again. Okay. The same way if request failed over here or here, the entire API call will be failed and you'll get the response back to the user. Okay. So that's the theory part of it. That's the theory part of admission webhook. Like, how does it work? Now let's go over to the terminal and let's do the demo of it. All right, so I have logged into Code Cloud free Kubernetes Playground, and it is using, I guess, version 1.33. So I can just do kubectl get nodes, and we have one control plane node and one worker node. And yes, it is using the latest Kubernetes version at the time of recording this video, version 1.33. Now, first, let's go ahead and check the all the enabled admission plugins that we have, right? So for that, let's check the API server pod first. So kubectl get pods hyphen n kube system. So it's part of kube system namespace. Okay, and the name of here is the kube API server pod. So I'm just gonna copy the name and I'm gonna run the command again, and this time I'll just provide the name as well. Okay, and let's generate the YAML of it with the help of -o YAML. Okay, over here you will see something with the name admission. Okay, you can search it like this or you can just grab it. So over here somewhere, let's see. Kube API server allowed authorize enable admission plugin. Okay, so as you can see, it says node restriction. That's one of the admission plugin that is enabled by default. Okay, and as I've said earlier, you can just grab as well. So grab admission instead of looking through all the YAML. So it says this is the node restrictions is the enabled plugin that is enabled already for you. You can also check the Kube API server manifest if you have access to the control plane node. So by default, it should be there in etc Kubernetes manifest, and then there'll be a YAML for API server, which is Kube API server. Let's run a less on this. And over here, you will see enable admission plugin. Okay, this is the same thing because using this YAML, the Kube API server pod was brought up. So this will be similar to what we have in the YAML. Okay, node restrictions is the default plugin that is enabled. Now, there are different other controllers that you can enable. So let's try to test out one of those controller. We'll enable it, but before that, I want to show you how does it work. So it's a mutating controller, mutating webhook. That means it will make certain changes to the objects. Okay, so I'm gonna try to create a pod in a namespace that does not exist. Okay, so kubectl run nginx hyphen n test. Okay, and I have to provide image as well. Image is equal to nginx. Okay. Okay, now what does it say? It says error from server namespace test not found. So if I do kubectl get namespace, the test namespace does not exist. So that's why the request was failed, which is valid, right? Which is what we expect to happen. But what if we have an automation in place which will create the namespace if it does not exist? Okay, so that's the part of webhook that we'll be using. Okay, so that's so there is a already inbuilt admission controller, and it's called namespace auto provision. So that would help us. Sorry, namespace lifecycle. Yeah, earlier it was namespace auto provision. Now it has changed to namespace lifecycle. So this is what we will be enabling. So how do we enable it? We go to the same directory. Okay, I think I'm in the no. Okay, let's go to the same manifest directory. Let's take the backup of Kube API server because we don't want to mess with it. Kube API server and underscore backup. Okay, now let's do a VI on Kube API server. And at the same place where we have the option of enable admission plugin, let's add comma and let's add another admission plugin, which is namespace Let me check the name first. If I'm namespace auto provision. Okay, yeah. So I have just copied the name from the documentation. Okay, so namespace auto provision. So this, so once like this work the same way, like what we have discussed earlier. Once you create a pod, that means you are sending a request to the server. It is authenticated and authorized, and then it will call the webhook to check if it is valid or not. And because we have a mutating webhook, which is this one, uh, no, so I'm calling webhook again and again. It's an admission plugin. It's an admission controller. Okay, so namespace auto provision. This will make sure that your namespace will be created if it does not exist while creating a pod. Okay, so I'm just gonna save this file, and this will restart the Kube API server. If it's a managed environment, then there are different ways to restart it, or you can just move this manifest to some other directory and update and move it back to this directory, and it will restart the API server. So let's just wait for the Kube API server and other control plane pods to come up. So let's do system. Okay, so it's currently restarting, so that's why you don't see anything, but it's gonna take a couple of minutes and it should restart the control plane. Okay, okay, now it's doing something, I guess. Yeah, because like we were getting connection refused earlier because the control plane components are not up, especially the Kube API server, which is responsible for accepting the request and uh, providing the response back. Like kubectl get pod is an API call to the API server, right? So if it is not up, that means we'll be getting connection refused. Okay, now it says, let's see, Kube API server is now running. Okay, so this is fine now. Now let's try to run the command again now that we have enabled the webhook. Okay, and if I do kubectl get ns, we still don't have the test namespace, right? And if I'm gonna run that command again, which is this one, run nginx in the test namespace. Oops, it says namespace is test not found. It shouldn't happen, right? Because we have the webhook enabled. So let's see what's wrong with the request. Let's check the Kube API server manifest, and let's check the enabled plugin. Okay, name auto provision. Oh, it's there. So ideally it should have done its magic. Let's just check the documentation. Okay, Kubernetes admission control, and let me just search it over here. Okay, so this admission controller examining all incoming requests to namespace resource and check if the reference namespace does exist. It creates a namespace if it cannot be found. Okay, and yeah, so this is there, and I can see it is enabled as well. This is the Kube API server. Let's check the other command, kubectl get pods hyphen n cube system, and the name was Kube API server control plane, something like that. Where it is, Kube API server control plane. Okay, so kubectl get pods this hyphen namespace cube system, and then hyphen o yaml grep admission. Yes. So even if we added that in the YAML, somehow it's not reflecting in the Kube API server pod. The changes are not reflecting over here. So what can we do? We can do a quick restart, or I'll just move this YAML first. Ideally, it should not make any difference, but let's just move this to a temp directory. And let's do the same for this so that it will force the restart again. Okay, now if I do kubectl get pods or anything, it will get the connection refused. Now let's move it back from temp to here, and this should restart the kube API server again. So let's wait for few minutes. Okay, I guess that was the only step, but let it come up and then we'll see. Okay, it's still coming up, the request. Okay, now API server is pending. Let's add a watch to it. Controller manager, scheduler, API server is up now. Okay, so now let's run that command again. Get pod scrap admission. Okay, now we see the changes are getting reflected. Now we have namespace auto provision from the, so there is a difference, like, so now from this command we are getting the values from the live environment, right? But in the manifest, the kube API server YAML that we have, that's the desired state of the server. So there was a disconnect between what is the desired state and what is the actual state. So we force the kube API server restart, and now the changes are there. So now if I do kubectl get ns, we still don't have test namespace. And now if I run the kubectl run command to create the pod, which is this one, let's see. Okay, now it created the pod even without the namespace, and if I do get ns, so it has created a new namespace. Let's try it one more time. Okay, let's give any other name. Let's call it namespace name Piyush. Okay, created. And if I do kubectl get ns, the namespace is also created just now. Okay, so this is the beauty of admission controller, and specifically this was mutating admission controller that we have just checked. Okay, and now let's try to work with some other built-in admission controller. So I'm gonna copy a YAML over here and I'm gonna walk you through it. Okay, so let's go back, and there's nothing. Let's give it something. Let's call it demo.yaml. Okay, what does it have? It will create a new namespace with the name quota demo, and then it will create a resource quota. And the resource quota, we are setting some limits that request should not go more than 1 CPU, and memory should not go than 1 GB, 1 GI. Limit should be 2, and limits of memory limit should be 2 GI for 4 pods. Okay, so like the pod limit is 4 for the cluster. So this is a resource quota that we are creating for quota demo namespace. Okay, we are restricting the namespace with certain resources, like what can be created and how much can be created. Okay, so let's apply this YAML kubectl apply -f demo. Okay, created the namespace, created the quota. You can verify kubectl get ns. So here is the quota demo, and you can verify kubectl get resource quota. There was a different namespace, so let's go -a. The resource quota name is quota demo, and here are the limits. The pods are 0 to 1. That means 4 are the allows, and 0 is the current number of pods in that namespace. The same way, requests and limits for CPU and memory have been specified in the resource quota. Okay, now we'll try to create a pod that will exceed this limit. Okay, so let's create pod.yaml. Okay, in this we are creating a pod. Okay, just give me a second, I have to pause. Okay, so we are creating a pod with the name big pod and the same namespace in which we have created the resource quota, and in that there is a container, and the request of for memory is 2 GB. Okay, so this exceeds our quota, and the CPU is 1, which is fine. But let's see what was the limit for this. So as you can see, the memory limit is 2 GB, but memory request is 1 GB over here, 1 GI, right? So memory request was 1 GI, but what we have created is memory request with 2 GI, which exceeds our quota. Okay. So if I just apply the changes, kubectl apply -f and pod.yaml. Okay. What does it say? Error from server forbidden. Error when creating pod is forbidden. Failed quota. We must specify limits CPU for this, limits for memory for this. Okay. So the quota has been breached. That's why it was failed, and that's why this validating admission plugin provided the error. It did not try to adjust the quota, or it did not try to adjust the YAML, because that's what mutating webhooks does, right? But this is the admission controller, so that's why it did not do. Oh, sorry, this is the validating controller. That's why it did not do that. It just checked whether it is allowed or not. It's not allowed. It failed with the validation error. Okay. Now let's try one more mutating webhook controller. Okay, so I'm just gonna create a new YAML, and we will create a limit range, right? So the limit range that we have specified is there are limits. So this is the default limit that will be applied to any pod which does not have limits and requests. Okay. So what does it say? The type is container. That means at the container level, if there is no request and limits, then apply these defaults. Default of memory 512, default of CPU 200M, default request should be these. Okay. So the limits are double the request, but these are the default limit range that we are applying to the same namespace. Okay. So kubectl apply -f limits. Okay, now let's say kubectl get limit range, and it's there in the other namespace, which is quota. So this has been created. Now let's try to create a pod without the request and limits. Okay, so if I just do kubectl run nginx and -image nginx, and namespace should be the same, which is quota demo. Okay, now let's do kubectl get pods in that quota demo namespace. Okay, it is running. Let's do a describe on it. Kubectl describe pod and the same namespace. Okay, now let's see its request and limits over here. Okay, you see the limits request for CPU memory, it has been applied to the pod, even though we created the pod without any limits and request, even though we created just with the simple command without using the defaults. So it automatically applied the default requests and limits, and that's what was done with the mutating admission controller. Okay, so we have checked both um, we have checked for validating admission controller, and we have checked for the mutating admission controller, right? So try it out yourself, and there are other like there is webhook as well, like validating webhook configuration and mutating webhook configuration. So that's the another webhook that you create by yourself, but I've not gone through it because it's out of scope from CK perspective. You will not be asked to create your own webhooks. So this is what we have used, the already inbuilt webhooks that we have, and we have tried to work our way through it. So I hope this was pretty helpful. If did, so gives it a thumbs up and try to share it with your friends and colleagues. And I will see you soon with the next video, day 52. And in that video, what are we going to learn? I'm not sure yet, but you will get that video tomorrow. Okay. So thank you so much and have a good one. Take care.